Okay, well, let's see here. Nope, that's not what I wanted. I'm always messing with things here. So let's see, I don't have a camera. So what we're going to do is go to there we are. Yeah, welcome to the coffee and a weather map with Jeff. I just wanted to kind of point out a few things here today. I know we have a winter weather advisory out. I'm at home. It's my day off. I'm killing some time while I'm doing laundry, dishes. Oh, the dishwasher's doing that, and I've already had some phone calls that I made that to get a hold of things. I need to pick up Mary at 2. It's currently quarter to 1. So I thought I would do a little bit of this. I just kind of wanted to go through and um, show what's going on with some of the weather things going on around here. The first thing I want to show is this. I guess it's this map here. Here, I'm going to close it on my other browser. So we've been advertising this, and I saw this in the on the when I was forecasting here a few days ago. And one of the issues that tends to happen with some of these systems along a warm front like this is depending on our wind flow. And I want to show a little bit about what's going on with that because that has determined a bit about what's happening here. I guess that's not going to work the way I thought it was. But sometimes it takes a while for the atmosphere to moisten up. Sometimes the models can be a little too aggressive. We try to work on getting taking that into account on stuff. But just to show you a little bit about this, let's see if I can do this. That's going to just move it. Let's see. So if you notice the hole that's in the middle of everything, let's see if I do this. Here, let's do. Let's do it as a markup. So I'm using a different app here so that it gives me the I. Yeah, I can't move the screen now. So I'm using a different app here to project my iPad. And one of the things I wanted to point out is that there is a front. I'm doing this as a dotted line. The warm front's just off to our south. Well, it's not a warm front per se. It's actually a stationary front. Something like that. And then I can change the color here to blue. Fill those in. Since stationary fronts tend to be represented by red and blue alternating lines, and usually I'd put the nubs and the little triangles on them in the way that they're supposed to be, but that's a little much, I think, right now. So, just for sake of time. So, what I wanted to point out is this hole right here. Nope, that didn't show up very well. Let's undo that. Let's try a different color. How about black? Okay, there we go. And let's see if I can show this a different way. Let's get the MRMS website up here. Doing this all on the fly. Here it is. And we will go to this monitor here. Hey, look at that. There we go. Okay. Are we looking at okay, so this is a poor representation. Let's try a different one. MRMS has its is great to overlay all these things, let's just try a loop anyways. But one of its things is it will try to, well, it kind of shows it. It tries to use the other radar sites to overlay everything. And when it does, sometimes it masks out certain features. So all the precipitation in this particular one is not hitting the ground, which is what I wanted to kind of talk about here this morning. So we'll get rid of that one. We'll go back to this. So here's the stationary front, which was at this was at 11 o'clock this morning. We just had the time change, so our Z times are now 4 hours off instead of 5, as they typically are during the when we're in standard time. And the low pressure systems basically are going to kind of ride right along this, so that the front doesn't go any farther north than what it is. That's why it's stationary. What you'll end up with is a nice bit where the moisture rides up over the front and it starts to precipitate. The only problem with that is, and we will get rid of, we're going to delete that. And let's see, I think I have, there we go. Let's go back to my tablet real quick, iPad capture. So what I wanted to show you here is this. So this is done, was one of the high-res models that's in a very short-term thing. And it's the current time. And then you see this little wedge. So the red is temperature through the column, or through the atmosphere over Gaylord. This is taken for the airport. And then this green one is the moisture. It's represented as dew point. You notice that there's quite a bit of space here between the moisture and the actual temperature. And what you would want more likely, let me zoom back out a little bit so I can advance this. And we can actually see, let's see, that's at noon, and that was at 11 o'clock. So you can see that there's been that dry layer of air. Well, what that does is it begins, it keeps the precipitation from hitting the ground, because if there's a large enough wedge in there, it will cause it to evaporate, or with snowflakes, sublimate, which means it's going directly from ice into the water vapor. So that's what we're having happen right now. Let's see. I was going to get. Oh yes, I know. College of DuPage. Weather analysis. I'll get that going here. Some of my favorite sites. And I want the satellite and radar. And I want specifically, I want radar. I want dual pole. I don't want Chicago. But that's because, radar selection. Here we go. I want Gaylord. All right, so let me switch us over to that real quick. Okay, so you can see here where my cursor's at. That it doesn't look like there's a lot of precipitation falling. And as I was showing that before, and I want to start the loop, which, there it is. I had to remember where they do that. Oh. So here's what's been going on, is that even though you see all these really great greens and blues showing that it should be precipitating, in fact, even watch this band to the south as I drag the cursor through there, it falls apart, like right around here. And that's due to this dry air. So what you want to be careful with when you're forecasting is doing this. And sometimes it's not evident in the way that the models present this. Sometimes it shows everything is, I just moved back to that. Back to the sounding again. Sometimes it shows up like this. There we go. That's what I wanted. Everything's saturated from the surface all the way up. Models do have a tendency sometimes, not always, but sometimes, of not getting the moisture all the way through the column, and the column just being just a column of air straight up from where you're at. And so what this is showing, and this is valid at 19Z, so that would be 3 o'clock this afternoon, is when it's supposed to be completely, all the moisture should be in that area. Even at 2 o'clock, we're still seeing some dry air. So we'll probably see maybe some flurries coming up here in the next couple of, next hour or so. And then maybe by, what did I say, 3 o'clock, then we'll start seeing something that's a little bit more like a snow. But what this tends to do is the models then start to overestimate the amount of precipitation that's coming out, which then affects our snowfall forecasts. So I noticed on this morning's DSS package. Let's see if I can get that real quick. I think I can. Yep. Oh, I haven't updated this. I'll have to do that. Come on. All right. So this is on the website, on the Weather Service website. So this morning they had this. Oops. Helps if I change monitors here so you guys can see what's going on. There we go. So what we're seeing is right here was this 2 to 5 inch snowfall area, which kind of dips into part of Charlevoix and northern Otsego County, a little bit into northern Montmorency, maybe right on the border of Alpena County. But, Presque Isle, Sheboygan, and Emmett were the ones that were the main ones for this 2 to 5 inch snow. And so it's hard for this to turn out the longer this dry air stays in here, which is like I was trying to say before. The models sometimes overestimate the amount of snow because they moisten things up too much. And we try to take that into account, but because of the number of observations for upper air, it can be a little daunting to try to get that in a real-time sort of sense. We are reliant on every 12-hour soundings, that is balloon releases. So at 12Z in the morning and 0Z at night, at least here in the U.S., which in the Eastern time zone is 8 a.m. and 8 p.m., that's when these balloons are done. So that can be an issue as we go through to try to make a very short-term forecast. Now, as the models start to acquire that data, they will start to slow things down, which is what I think has happened here. They slowed everything down because of that, and it could still be 2 to 5 inches, but it just wouldn't be surprising if we end up on the low end of some of these with in here, which is something that, as a meteorologist, that's one of the reasons we put these ranges in here, is so that people know that this is what could end up happening. It's not that 5 inches is going to occur. It's not that 2 inches are going to occur, but they are in the realm of possibilities between everything. So you just have to keep an eye on that. Anyway, let's see here. If I start this up, let's see if there we go. So you can kind of see how it's starting to moisten up because we're starting to get some returns farther down lower. And with the radar being right here, you can start to see that it's almost getting in there so that the radar is picking it up really close in. So we'll see. Probably over the next maybe hour or so, we'll probably start seeing some flakes, and then maybe some of this will come together. Now, because the actual front is farther south, let's see if I can add anything here. No, radar selection. Let's see, I can't put data on this one. I think what I need to do, let's go back up here. Yeah, let's do satellite and radar. And you can see how I do this live. 9. Quiet. Sorry, my dog is, he hears something outside, so he thinks he's got to bark at stuff. Localized sectors. Nope. Sub-regional. There we go. And then we are going to, that's the cloud cover. We are going to overlay, though, with a composite radar. There we go. This is what I want to show you. So we can put these all together here. This is one of the reasons I really like the College of DuPage. So you can kind of see with that, even though we've got cloud cover all day long, we still don't have moisture all the way through the atmosphere to be able to sustain snowfall. Now, it is snowing over here, and I think, where are my station plots or present weather we'll have? There you go. So these are the sites that are already starting to report snow. Oh, there's even a heavy and a moderate snow over here in Wisconsin. So with the expected front to just stay right about in this general area where the trough is, so this is the lower pressure pointing out where everything is, this is where we would expect the most snow. So, you know, 2 to 5 isn't out of the question, and the way that this stuff is looks like it's lining up is going right about through here for the axis, but we'll see. That could change as time goes on, so we'll have to watch out. So that's kind of what I wanted to do. Instead of doing a full map analyzation, was just kind of show what goes on sometimes with all of this. And so I know that at the office they're not scrambling. They're trying to make sure that they keep everything up to date, especially as the new computer models come in. This is the time of the morning when things are coming in. Let's see here. We can look at tropical tidbits. I use that one as well. And tropical tidbits is was done by now a doctor of meteorology, but at the time he was just a student, and then a doctoral student. And he's been doing this on the fly, and he has some really great discussions during hurricane season. So I love to listen to that because he breaks it down so that it's easy, but yet gives enough technical information that I can see what he's talking about and where this is going. So let's see here. This is the GFS, and it said at currently, what is this? Let's see, which model? Oh, this is the 12Z GFS, which is the 8 o'clock in the morning. So, and so far we are at, let's see, 6Z, or 6 hours. So that's 18Z. So that's 2 o'clock in the afternoon. So its update has now shown that we should be, by 2 o'clock, updated everything. We can request a sounding. And it says that by 2 o'clock we should be saturated. Kind of maybe still, again, like I said, a little overly aggressive. So we'll look at the mesoscale. Now, one of my favorites is the WRF ARW because it tends to do a better job with lake effect, but it doesn't always do a fantastic job. Now, the ARW for 18Z, which is just coming up here in another hour, still shows that dry layer right in here. So not completely saturated up here by Gaylord. However, if you go a little farther south, let's see if I can't remember if I can change that. Not on the fly like that. I got to do this. So say down by the office, which I haven't seen. I should probably look at one of their webcams. It should be saturated. And the office should be having snow, which it was starting to show on that radar that it was pretty close. Pretty doggone close. So we'll see how this turns out. So far, I like the ARW's idea. The FV3 is a newer model. They took out what was known as the NMM. The FV3 is like a high-res version of the Global Forecasting System, the GFS model. It looks like it is way too saturated. It is the 12Z, and this is at 18Z, and it says, yeah, so you back it up an hour. Yeah, it's trying to overdo the precipitation way too much, too fast, too soon. That's probably why the GFS looks the way it is, because these are very similar models. This one's just a very higher resolution version of it. Sometimes I like to look on this page. I can get the ARW2, which is one that's done by the National Severe Storms Lab. Oh, and then that looks a lot more representative about what we were seeing on the radar earlier. So you got a little band going in here, and then there's another sort of band light one trying to form up south of here, and then there's this dry area that's all in this general direction. So it's just taking time for everything to get through and working before we get everything. Oh, there's my statistics. No comments. Okay, that's okay. I'll probably get comments later. Let's see here. Just one other model to take a look at. The 3 kilometer NAM. That's also become a favorite of mine. Ooh, even drier. And it's just trying to show that something right about now at 2 o'clock coming up should try to start reaching the ground. And then the better stuff is over here in Wisconsin and heading across Lake Michigan, as we saw on the radar and some of the observations. So, with that in mind, let's see here. What do I want to go to next? We'll go to my iPad capture. On pivotal weather, another favorite site of mine, and that's the GFS. Like I said, the GFS looks like it's overdone its stuff. Here, let's go back to the ARW for the current time. Yeah, I mean it may be a little overly aggressive as well, but it's not terrible. So we can kind of look at that. But I think that is where I'll leave it. The snow is coming. It's just taking its time getting here. The atmosphere is trying to add the moisture it needs to support the snowflakes all the way down. I know for some people they would prefer that the dry air just stay in place, but that's not going to happen. But anyway, that's where we're at. And I just thank everyone who watches this probably later on, because I don't think I have a whole lot of viewers currently, which is okay. I don't do these things announced, and I don't expect people to pull all these together when I do them. So thanks everybody, and I will say see you later.